Divide and conquer. Divide and conquer is a computing paradigm where we divide a problem recursively into subproblems and then solve each subproblem on its own and combine the solution of these subproblems to obtain the solution of the entire problem. So this is the problem which is split into different subproblems. These subproblems are again split. So after all the subproblem solution is found, these solutions are merged to form a single solution. Divide and conquer consists of three main components. Divide. The problem is divided into smaller instances called subproblems. Conquer. Conquering the subproblem to solve them recursively. When the subproblem is trivial, we solve them in a simple manner. Combine. After computing the solution to all the subproblems, we combine them. Why divide and conquer? It solves difficult and impossible looking problems very easily. It reduces the degree of difficulty by dividing the problem into simple subproblems, better time complexity for a few problems, and it uses memory caches effectively. Analysis. Let the size of the original problem be n. T of n be the time. D of n is the time taken to divide the problem. Let there be k subproblems of size n1, n2 till nk. To solve the ith subproblem, the time taken would be T of ni. The time taken to combine all these solutions of the subproblem is C of n. So T of n will be summation I equal to 1 to k T of ni plus the separate time for D of n plus C of n. Divide and conquer based algorithm. There are various algorithms based on divide and conquer paradigm. Example are merge sort, inversion algorithm, skyline points algorithm, integer matrix multiplication, etc. Merge sort. So input is an array of n elements. So output is sorted array of n elements. Step. Divide its input n into roughly 2 equal parts of size n by 2 each. Compare. We then solve each subpart recursively. During the trivial case, when we have only one element in each part, we sort them accordingly to their value and position them correctly. Combine. We have already solved the subproblem for the left subpart and the right subpart. We then solve for the whole problem by comparing the head of both the arrays one by one and copying the smaller value to an auxiliary array until the entire array is sorted. So this is the pseudocode for the merge sort. So merge sort of array ij. If I less than j, then k equal to floor of ij by 2, then it is recursive calling of merge sort array I to k, that is the left part, then the merge sort array of k plus 1 to j, that is the right part, and then we merge, that is merge of array arr ij k. It merges the left and the right array. So this is the array that we wish to sort. So there are 16 elements. So at the 8th position we can split it. Again this can be split at this position giving these two subarrays. This can be again split at this position giving this smaller subarrays. Finally we will get an subarray that will have only one element each. So similarly in the right part also we break until we get until we get the arrays in which there is only one element. Now after this step, see, this is the left array. So this is the final stage in which we get the array of one element each. So now further division is not possible. Next we move on to merging. That is, see, 18 and 26 can be merged, and during merging we will sort 18, 26. These are already in correct order, so it will be merged like this. 32 and 6 while merging will become 6 and 32. Similarly, while merging this 4, first there will be 6, then 18, then 26, then 32. Similarly, we will repeat for this side also, and finally while merging these two array, we will merge in the correct order. So this is the entire example of merge sort. Next is inversion. Input is an array of n element. Output is number of inversion, a pair of indices ij such that I is less than j but a of I is greater than a of j. The steps are: divide. Separate list into two pieces. Compare. Recursively count inversions in each half. Combine. Count inversions where a of I and a of j are in different halves and return sum of three quantities. The inversion pseudocode. So sort A of P to R, one element or fewer, no inversions, midpoint. Count inversions in the left half, sort the right half, merge and count inversions. Merges A, P equal to P from P to M with A of M plus 1 till R. Initialize indices, inversion counter. While both the subarrays are non-empty, take next item from the left subarray, increment the inversion counter. Take next item from the right subarray, copy extras from the left subarray to B, increment inversion counter, copy extras from the right subarray to B and copy back B to A. So this is the array that we wish to invert. So similar to merge sort, we will first split it until we get one element each. And after that, from each element we have to merge for inverting them. See, these are in correct order, so this is correct. For this we will require one inversion, that is first 1 then 4. For this pair again one inversion will be there. Again for this pair an inversion will be required. So in this stage there are 3 inversions. In this stage, how many inversions are required? See, for we will merge this 2 and this 2. So for this there will be 1 and 4 and then 6 and 8 will go in this position. Calculate the number of knots formed. 4. Here there are 4 inversions. Again in this place there are only 2 inversions. 2 knots are formed. So 6 inversions are there. So similarly from this place again we will place all the numbers in their correct position and calculate the number of intersecting knots. So there are 9 inversions present and finally the output is what we require. The upcoming topics are skyline point algorithm and integer matrix multiplication. Thank you.